Hi, everyone. My name is Ben McDonald. Like Alex just mentioned, I'm a software engineer working on the hardware management team at HPE, and I'm an open source contributor to OpenCHAMI. And so today I'm going to be talking about some of the work that's gone into building a tool for the automation of OpenCHAMI service development. I've worked with Alex, like he just mentioned. Most of the development for Fabrica, the development tool came out of Los Alamos National Laboratory, but the free tracker that we're using as a case study here was developed in parallel at HPE and LANL, so that's what I'll be talking about today. And my images are not showing up. That changes things. Okay. So to get you all ready for this talk, I was going to call out one of Aesop's fables called The Ant and the Grasshopper. There should be an image that you're not seeing, but I will just read you the story instead. So one bright day in late autumn, a family of ants were bustling about in the warm sunshine, drying out the grain they had stored up during the summer, when a starving grasshopper, his fiddle under his arm, came up and humbly begged for a bite to eat. "What?" cried the ants in surprise. "Haven't you stored anything away for the winter? What in the world were you doing all last summer?" "I didn't have time to store up any food," whined the grasshopper. "I was so busy making music that before I knew it, the summer was gone." The ants shrugged their shoulders in disgust. "Making music, were you?" they cried. "Very well, now dance." And they turned their backs on the grasshopper and went on with their work. And so now I hope as a community in HPC, we're a little bit more forgiving than these ants might have been. But I think for the most part, we can think about this story we can think about the ants as sort of being the standards compliant, steadily making progress part of software development. Whereas now that we have kind of like AI assisted development that works very fast, developers can be a little bit like this grasshopper, kind of throwing things together and getting a little bit lost without the ethic of the ant. But both are valuable. We can't have one without the other. And so, And so just to frame that problem more concretely with what's actually seen on the slide, since the pictures aren't coming through, as a developer, I can tell you that getting open source developers to adhere to project standards is hard. I know it's hard for me. And so at the same time, with the way software development is going, AI-assisted vibe coding makes it even harder. And so vibe coding is a term that came out of one of the OpenAI guys, but it basically means coding without writing any code, just essentially framing a problem in plain English and letting AI write it for you. And so to further elaborate on that problem here, so open source, I wish the pictures were coming through, but open source consensus and standards settings requires significant time. You would be able to see in this picture essentially just like a small piece of all the parallel discussions that are going on at OpenCHAMI in any given time related to standard setting. We have like 50 of those going on all the time. And so I just had a complicated looking picture up on the screen to show that. And so, so it's unreasonable for developers to keep track of every single one of those issues, essentially, stay up to date on all of that. And so on top of this, site developers are operating on deadline-driven schedules that often require functional software independently of that consensus timeline. And people often, like a standard solution offered here is something like code generation with open API specs, because you're standardizing a API, like why not just build everything off the spec? But those don't solve all this problem. They still leave a lot of the decisions up to individual developers, which can broaden the gap between one service and the next. When we're building an open source set of services, we'd like to have all those services feel as consistent as we can and adhere to those standards at the same time. And so now moving on to the concrete example, which is where this actually came into practice with HPE's partnership with LANL on this project. So essentially the problem here was that LANL required an operational through service for a new machine bring up that HPE was providing. And so that meant there was a hard deadline on when that was needed, because the real system was coming in onto the floor. And they wanted to know what was actually accessible on that system. We need some way to validate what's going on here. And so what a fruit tracker really is, you can think of that as like a tool to validate physical hardware that actually arrived on the floor against what we at HPE had actually told them would be in the machine. And more broadly, it's just a way to track and store all of the hardware components on the system and see what's changed over time and that sort of thing. And so this deadline that needed real code because of this machine bring up was a problem because there were still tons of open design questions about API standards. And so as a developer, I was kind of like, what am I supposed to do here? Like if I choose to write the code now, it's just going to need to change, and we're going to end up having to throw all that code away in time and all that development effort. But if I wait until all the standards are decided upon by like that independent process that I'm not really a part of, then the user site's in trouble. Like they don't meet the deadline essentially. So yeah, in between a rock and a hard place there. And so luckily for this, another time my picture could have come through, but luckily for this, this was right around the time when Fabrica was being developed at Lano, and it was close to production use. And so I'll get into here what you can think of as the ant going fast. We're calling the Fabrica approach here. And so Fabrica is a code generation tool that inverts the typical workflow of service generation. Rather than just using open API specs like I mentioned, when you use Fabrica, you just write some native Go structs, which means the data model is really the only part of the code that a developer needs to write and have in hand to get a fully functional REST API that can be tested against an actual use case on a real machine. And so I think on the slide I had like the picture of the code that you need, but essentially you can think of it as a developer just needs to write like 10 lines of code, then you have a full functional REST service. And so the way that Fabrica works is you have API structural standards that's being decided on by independent groups, decoupled from like core application logic, where the framework itself is what is generating things like the transportation layer, event handling, and state reconciliation, like those complicated architectural questions that all services need. Very common, or a lot of similarities between different services. And so what that actually means, since it's separate like that, is that the standards for, as the standards for OpenCHAMI change, the Fabrica code base is the only real code base that you need to update. So you essentially just make sure you've got it right once at the top Fabrica level, and then you can push that out to all the existing services that were built on top of Fabrica, and they'll just automatically incorporate those changes, pulling in that like top level standardization step that's gone in. And so since the specific application logic isn't standardized, like, you can have your fruit tracker logic that you wouldn't want to share across services. That's the work that developers done for just that unique service, and that doesn't change, that remains unchanged. So even though they might have changed something like the way events are emitted in OpenCHAMI like as a broader project, the service still remains functional and the code doesn't have to get thrown out. And so to explain why is this image coming through? But yeah, to explain, and it's not fully coming through, it's like 75%. but to explain the Fabrica architecture a bit better, here's like just a comparison between Fabrica and KubeBuilder. And so if anyone's familiar with KubeBuilder, KubeBuilder is very similar to Fabrica, only it's designed specifically for Kubernetes and uses Kubernetes-style resources and all those sort of definitions and things to really make things work. And so Fabrica can be thought of as like basically the same thing as KubeBuilder, but the main difference is that KubeBuilder requires a Kubernetes cluster, etcd, all those other Kubernetes environment requirements, which makes sense for that use case. You're using it within this context of a Kubernetes cluster. Whereas Fabrica services are kind of standalone services depending on nothing other than Go code. Nothing other than Go code at the very basic level, I guess. But what this means is you can run it on your laptop or on a supercomputer on bare metal or in the cloud with Kubernetes or without it, and it still works the same. We just have a standalone Go binary. And so getting back to that previous point from the last slide, the only things you need to write as a developer is a Go struct and any custom logic that's written that's unique to the service. And then Fabrica will give you that self-contained Go binary. Yeah, and so Kube Builder is very similar to Fabrica, but it doesn't lend itself as well to HPC, and so that's the niche we're trying to solve here. Yeah. Yeah, that one's coming through too. Okay, so yeah, we've talked about the problem of a new system bring up at Lano and the way that Fabrica works. Now we can talk about an actual application of this in practice, which is the fruit tracker I've been talking about throughout. And so just to quickly outline the development cycle here, we had an initial simple model that just, it was really just a simple CRUD model. And we got that working in about a day with Fabrica. And really all we did was define the resource model, like those 10 lines of code I talked about. And then we pushed the Fabrica button, and we had a full service ready to test. And then after this, we got some feedback that required some changes, and we were able to change just like a small subset of that code to make that happen. So it was another quick feedback cycle here. We didn't have to rewrite the whole code base because Fabrica really keeps things separate and isolated. And so in our first iteration, the way things were set up was that you had your fruit tracker service, which was basically just a passive data store, and then we had a standalone collector that was posting every single device individually. But in the second iteration, we switched to a bulk snapshot model where the API was handling that complex logic of keeping track of what all has been posted at any given time and the changes over time. But the exact specifics of like how the service implementation went aren't really important here. I think just the point I'm trying to make clear here is that Fabrica allowed us to like rapidly prototype something and get feedback in a development cycle in terms of like days rather than months. And that's much quicker than traditional software development allows. As I'm sure many of you all know, like a lot of traditional HPC software operates as proprietary code with like fixed release cycles. So the sooner you can get feedback on something is like several months in the case of a lot of codes. But now that we're moving towards open source development with OpenCHAMI, we've cut this down to a couple of days, which is very exciting. Lets you do the work with the customers, which is what matters. So yeah. So now just to revisit that vibe coding problem I mentioned earlier. So vibe coding, basically just writing code with plain English and letting the AI actually do the coding for you, just describing the code yourself. And so that's great in a lot of ways. It's super fast, and it can do a lot of great things, as I'm sure all of you have experienced at this time. And I think depending on your stance, like AI is a lot better at writing bug-free code than I am. I don't know about you all. But so the probabilistic nature of AI coding can introduce like a lot of inconsistency when you've got a lot of services like we do in OpenCHAMI. Like you can imagine one person writing a service and they give their AI a prompt. They might end up with like one service architecture with like, one sort of event bus, one sort of HTTP handler, just like, whereas another person might end up with like the exact same prompt with something drastically different just due to the nature of probabilistic AI models and how they work. And so this is one of the things Fabrica is great for. Like it's designed to remove that layer of indirection that lets the AI model decide for every service how it wants to generate the architecture. And it does that just by taking the architectural decisions out of the AI's hand and then letting developers, like once the groundwork's been laid, then at that point they can figure out the remaining 5% of the code base that's actually unique to each service while like the boilerplate is handled for you essentially. And so you'll see in this picture here that now is actually showing up that there's just like a bunch of LLMs generating a bunch of like random disjoint services all trying to play together in not the nicest way. Whereas with Fabrica, you kind of have each service is relatively consistent with that base, that core 95%, and then the individual stuff that's not decided on by a committee, but rather like the needs of an individual application are what's really unique from service to service. And so finally, to sum things up, we talked about the ant and the grasshopper. You didn't get to see the first image, but it would have made more sense in this context. We talked about the fruit tracker, and we talked about Fabrica. And so all of that comes together to tell the story of how Fabrica let us develop like an open source fruit tracker that was able to help validate the machine state of an HPE machine delivered to LANL in time for the machine bring up. And so initially this was kind of seeming impossible with the requirement of waiting around for like the perfect design specification to be laid out for the entire lifetime of the rest of the project before writing even a single line of code. In fact, those discussions are still going on today, I can tell you. But yeah, but instead we were able to make progress on a service that won't be thrown away as those decisions are made with the usage of Fabrica. And so this means you can think of the development workflow transitioning from a serial dependency of like competing deadlines into like a parallel workflow where standards in development aren't at odds. And so all that being said, this is how the ant and the grasshopper can finally work together. So thank you. That was the end of the talk. All right, yeah, any questions or?
Come on, I got all the way up here. No questions. There's a mic over there.
So do you see fruit tracker being used post-delivery, not just for validating the system setup, but as you replace system components and, throughout the lifecycle?
Having worked on it, I can tell you I would love for that to be the case, but I'll let Alex answer the reality.
Yeah, I would assume so. The definition of a FRU is a field replaceable unit. So anything in our system with a serial number, when we send it out for RMA, I mean, not that we ever will, of course, all the hardware will be perfect when you deliver it, and we will never have to RMA anything. But when we do, we're going to want to know, like, which serial numbers got RMA'd. When they came back, did they go back in the same place? All of that stuff is what it's for. So it's more of a day 2 operations thing than a day 1 operations thing. All right. Thanks. You can find Fabrica and OpenCHAMI on GitHub and our fruit tracker and all of the other Fabrica-generated services that are part of the system. So thank you.